You guys ever play Risk?
No.
Like the old school day game? I was playing that. Got everything except for Asia, then I'm gonna rule the world. Game can get really political though if you actually play it in person. I remember those days back with the dice and stuff. Good times. We got 1 minute. Yeah, the results of the poll were to have the test be
Easy and closed notes?
Yeah. So only 8 people responded though. 6 were for easy closed notes, 2 wanted a crib sheet. So no one voted for open book.
No, because you were going to make it hard.
I mean, I'd have
Exactly. I voted for the easiest possible answer.
Yep, so today I'm going to go over a previous test and I'll send everyone the notes via email announcements and I'll post the lecture, and I also have another video where I go over this, so it's shorter, so if you wanted to go over that, there'll be several options for you. But does anybody have any questions about anything before we start? Yes, please, Michael.
Are these similar questions going to be like one of the tests?
Yeah.
Okay. All the same? Which is
not all of them.
Different?
They're similar, so like I do ask a question about like what the mass of something, in this case it's fluorine, in this test it's something else. So I mean, some of it's like that. I mean, there's one question that is exactly the same, but but I mean, they're all kind of related in some way, shape, or form. Some have the same questions with the numbers changed, for instance. So, let's see here, what else? Oh, so same idea, 20 questions, multiple choice. Show your work for partial credit. This one is just straight through. This one I gave it Manoa. So, no partial credit, but you guys get partial credit. And you get a periodic table, some equations, charts, like solubility charts, and you're allowed to ask questions. The questions you can ask are definition questions, clarification questions, conversion questions.
Answer questions.
You're not allowed to ask strategy questions. So, how do I do number 2 is an example of a question I will not answer. Or maybe a technical one, so what is the, you can ask me what the equation for figuring out the molecular weight is, for instance. But at the same time, if it's a strategy, is it doing this way? I might answer with the equation. Like, is this how I figure out the molecular weight? I'd say the equation for figuring out the molecular weight is this. That makes sense. So I'll give you clarification questions, but not strategy points. So, any questions with that? All right. So, I will try. What's that? I'm sorry, what was that?
That was side table.
Okay, side discussion. All right, that's cool. Okay, so start with number 1. And I'll try and, I'll do different colors, so I'll try and explain it for people that are colorblind. But how many of the following compounds are soluble in water? Again, you're going to get the chart. But in the chart says all alkalis are soluble, so lithium and potassium are soluble. All ammonias are soluble. And then you have to look at this, and hydroxides tend to be insoluble. I might as well just show you the chart. You'll get this. So alkalis are soluble, ammonia is soluble, hydroxides tend to be insoluble, and copper is not an exception. Therefore, copper hydroxide is insoluble. So it's this one, this one, this one, and that means there's 3 that are soluble. Questions with that? So As discussed, don't forget to come in your kilt on Wednesday. For anyone who's come into class late. So, all right, number 2 in red. A fictional element is found to have these masses with these abundances. What is the atomic mass of the element? The way you solve this one, it's the sum of the mass times the abundance. So it's going to be 22.176 times 0.45 plus 23.1847 times 0.45 plus 24.1934 times 10%. It's like the 0, but that's the way you solve it. So it's just this times 0.45, this times 0.45, this by 0.1. Questions with that? Nope. Okay. I'm not sure. The answer is going to be A or C. I don't know which one it is. Do you really want to know the answer?
The answer key is at the bottom.
Okay. Oh, it is?
Yeah.
So 2 is A. Alright. I knew it's A or C, I don't know which one. Okay. So which precipitate is likely to be formed containing these 4 things? So I'll do pink. So you have to look. So we're going to have barium hydroxide, barium carbonate, sodium hydroxide, and sodium carbonate. And what I'm doing is I'm combining the positive ions with the negative anions. So those are the ones that are going to bind. And then you have to decide if any of these, which one of these is the least soluble. So for the sodium, these are all soluble. And if you look at barium hydroxide, this says slightly soluble. And barium carbonate, this is insoluble. So the thing that's going to form a precipitate is the barium carbonate. And again, I'm getting this from looking at a chart like this, where you see carbonates and phosphates are insoluble with the exception of the alkalis and ammonia. And hydroxide, if it combines with barium, it's slightly soluble. If you can, when hydroxide pairs with barium, it's slightly soluble.
So this is one of the charts that you'll give us?
Yes.
Okay.
It was C, yeah, for which one's not soluble.
It's barium carbonate, whatever answer that is. Yeah, barium carbonate. Right here, because look at the ions. So the barium is going to bind with hydroxide or carbonate, and sodium is going to bind with hydroxide or carbonate. And the one that's the least soluble is barium carbonate. So that's the most likely precipitate to form. Questions with that one? I'm having a hard time reading your faces. Is that good? Are you following, or is this not good? Do you need more explanation?
So far, so good.
Okay. All right. What volume in milliliters do you need 0.0887 molar magnesium fluoride to make 270 milliliters of 0.0224 molar mag fluoride? Okay, so in brown this time, use the equation M1V1 equals M2V2, and you just solve for a volume. So volume 1 is M2V2 over M1, which is, so M2 is 0.0224, 275 all over 0.0887. So what is that? It's about a fourth of that, which is about 70 milliliters. So it's A or B. So, and the answer, what is 4? I'm curious. It's A or B. 4 is B. So, okay, so this one again, use the dilution equation. Concentration of one times the volume of one equals the concentration of the second times the volume of the second. So we solve for volume, that's what they're asking for. And we have the concentration of the second times the volume of the second over the concentration of the first. And then we get about 70 milliliters. Any question? Or are you stretching? Okay. Does that make sense? Questions with this one? You can stretch.
All you have to do is put the mass
Yep.
2 over volume 2 over mass 1.
Yeah, molarity.
Yeah.
Concentration.
And
Yes.
you get the answer.
Yes.
So you just need to memorize that formula.
I give you this formula.
But what about the other one?
That's using algebra to solve for it.
Right,
Other questions? Okay, ooh. Gotta use my brain for this one. What is the empirical formula of substance that contains 2.64 grams of carbon, 0.444 grams of hydrogen, and 0.352 grams of oxygen? Okay, so I'll do this one in black. And empirical formulas, so we have 2.64 grams of carbon, 4.44 grams, oh, too many.
0.4.
Yeah. 0.444 grams hydrogen and 3.52 grams of oxygen. So carbon, mole carbon over 12.01 grams carbon, mole hydrogen over 1.008 grams hydrogen, mole oxygen over 16 grams oxygen. And where am I getting these numbers? I'm getting these numbers from the periodic table. They're the ones on the bottom, like here. Carbon, if you can see that, it says 12.01. And you get a periodic table. So you do not have to memorize this. Unless you want to, but there's no point. Okay, so this becomes 0.222. This becomes, I shouldn't have just that. This becomes 0.44. This becomes 0.22. And I know that because I did this morning, and I remember it. So you divide everything by 0.22, and you get 1 to 2 to 1. So that means you have CH2O, like that. So the ratio between them is 1 carbon to 2 hydrogens to 1 oxygen, like so. Is that too, you're squinting? So does this make sense? You're saying, what's the empirical formula? Something that has 2.64 grams of carbon, 0.444 grams hydrogen, 3.52 grams oxygen. So you convert to moles by the atomic mass periodic table, and then you get a 0.22 to 0.44 to 0.22 molar ratio, and you divide by the lowest. The lowest in this case is 0.22, and you get 1 to 2 to 1. So that means you have 1 carbon to 2 hydrogens to 1 oxygen. So questions with this one? No questions. It's all so clear, and it's such a review. You guys are just going to blow through this test, and it's going to be the most amazing test ever. That would be awesome. Okay. Determine the percent yield of a reaction that produces 28.65 grams of iron when 50 grams of iron 3 oxide react with excess aluminum by this following reaction. Okay, I'll make it rusty for a second. red. Okay, so this is a limiting reagent problem, but it's telling you that the oh wait, that's the end product. It tells you what the limiting reagent is because it says excess aluminum. So dimensional analysis, you start with what you know. 50 grams iron to oxide. And you have to look at the balanced equations. So, oh wait, yeah, mole iron 3 oxide. Okay, so let's see here. So Fe2O3, this is 55.85 times 2 plus 3 times 16. And again, those are the numbers in the bottom of the periodic table, so that's what, 0.7. 110.7 plus 3 times 16 is 48. That's 158.7, I think. 158.7. Let me see. I'm a little tired. Let me check my math. Okay. 55.85 times 2 plus 3. Oh, 159. I'm off by 1. How did I get off by 1? Oh, because the 0.85 carries the 1 over. Shoot. All right. Glad I used my calculator. All right, so get the molecular weight of iron. Now we want to know there's 2 moles iron to every mole Fe2O3, and that is highlighted there in purple. There is 1 mole of iron Fe2O3 to 2 moles Fe. I'm getting tired of calling it iron 3 oxide. Okay, and then 55.85 grams of iron to every mole of iron. And if we do this, we get 50 divided by 159.7 times 2 times 55.85. And we get 34.97 grams iron. And given to you, the percent yield is the actual over the theoretical times 100% equals 28.65, which is given to you, 34.97. So 28.65 divided by 34.97. And this is equal to 81.93%, which is right there. Okay, recap for this one. What's the percent yield if you start with 50 grams of iron oxide and if you get 28.65 grams of iron? Well, it tells you that the iron oxide is a limiting reagent because it says excess aluminum. So you look then to the dimensional analysis. 50 grams, it's Fe, not F2. Oh, Fe. 50 grams iron oxide, and calculate the molecular weight, 159.7. Then by the balanced chemical equation, there is 1 mole of iron oxide to 2 moles iron. So you have this step right here, and then atomic mass of iron, and you get 35 grams of iron. Percent yield is actual over theoretical. You have 28.65 over 35 is 82%. And that's your percent yield. Questions with how to do that? Okay. What species represented by the following information? So I'm going back to blue. So you have to look to an element
All protons,
with 12 protons,
so it has a 2 plus charge,
and this is magnesium.
so magnesium 2 plus.
So it's yes, magnesium plus 2 because since it has 10 electrons, so 2 less electrons, which implies a plus 2 charge. So it's magnesium plus 2. If you wanted to go all out, you could say this is magnesium 12 plus 2. 12 plus 14 is 26. So the top number is, so let's see here, this is the charge. This is the protons plus the neutrons. And the bottom number is just the number of protons. So, but it's only asking for magnesium. It doesn't include the isotope. So it's plain old magnesium plus 2. Questions with this one? And the plus 2 comes from the fact that there's 2 less electrons. 2 less electrons means that there's 10 negative charges and 12 positive charges, so that means the overall charge is plus 2. If there are extra electrons, the number of electrons gives you the negative charge. So for instance, if this one had 14 electrons, that would be a minus 2 charge, because there'd be 14 negative charges and 12 positive charges, and you'd have 2 extra negative charges, so it would give it a total negative 2 charge. Questions with this one? All right, how many moles of copper oxide can be produced from 0.9 moles of, so how many moles of copper 2 oxide can be produced from 0.9 moles of copper 1 oxide by the following reaction? You can, well, if you want, you can notice that there's a 2 to 1 molar ratio, or a 4 to 2, if you will, but 2 to 1. There's twice as much copper CuO than there is Cu2O. So from that, you multiply by 2 and you get 1.8. That's one way you could do it. But if you wanted to be doubly careful, what you could do is do dimensional analysis, where you have 0.9 moles Cu2O, and then notice there are 4 moles CuO to every 2 moles Cu2O, and this is going to be 1.8. So whichever way works for you.
How did you do it the first
Yeah.
way?
Can you repeat that?
First way, there's twice as much of this as there is of this. So whatever you have of this, you just double it.
You find the mass of that and then multiply by 2? Or?
It's just asking for moles. How many moles? You have to look to see what the problem's asking for. It's a simpler question. How many moles of copper CuO, how many moles of copper 2 oxide can be produced from 0.9 moles of copper 1 oxide, or Cu2O? Yeah. Yeah. So if you read the question carefully, sometimes it's a lot easier. Because I know we've been going through the long steps sometimes. These are the easy questions. So, questions with this one? How many grams of oxygen are formed when 6.21 moles of potassium hydroxide are formed? Anybody want to pick a color?
Green.
You say green?
Yep.
Green it is. Okay, so we want grams of oxygen, so we start off with 6.21 moles KOH, and that's because it's given right there. And so moles KOH, so times 1 oxygen, mole O2 to 4 mole KOH. And I'm getting that from here. And then 32 grams oxygen per mole oxygen. So what is that gonna be? That's gonna be around that's gonna be around 50 grams. Okay. So, okay. So how many grams oxygen formed with 6.21 moles potassium hydroxide? So we start off with what we know. We know the 6.21 moles KOH, and we're trying to go for grounds oxygen. So convert moles. So the moles are 4 to 1 here, 4 to 1 here, and then oxygen is 16. 16 times 2 is 32, and then solve it out. You get 50.
Isn't a mole O2 32 grams O2 over mole O2?
Yes. Is that hard to read?
Better now. I love better.
Other questions? Let's do purple. We haven't done purple yet. Or have we? I don't know. I guess we have. Anyways. Determine the number of protons, neutrons, electrons in the following. So remember this 4018x. So this top number, this is the protons plus the neutrons. This number is the protons, and if there's a charge, I'll just put the highlight there. The charge, so I guess it's positive. It's the protons minus the electrons is the charge. And in this case, since there is no charge, the protons equals the electrons, and the protons it's 18, and so this is 18, and then the neutrons equals the 40 minus 18, or 22. So it's this one, it's D. Protons are 18, electrons are 18, and neutrons are 22. So, questions with how to do this one? All right. Balance the chemical equation given below. Determine the number of moles of iodine that reacts with 30 grams of aluminum. Okay, what color should we do?
Gray.
Gray. Can you see gray?
Yeah.
Okay. All right. You can see gray. All right. So 1 part aluminum on the left, 2 parts on the right. So we put a 2 in front of the aluminum. 6 iodines on the right, 2 on the left. So we put a 3 there, and now the chemical equation is balanced. So you got that part? Okay, and determine the number of moles of iodine that works with 30 grams of aluminum. So we have 30 grams aluminum. So I think in moles, it's going to start from moles aluminum, and 27 grams aluminum. That's the periodic table. You don't have to have it memorized. And then there are 3 moles iodine to 2 moles Al, like so. So that's like 45, or that's going to be, that's about 1. That's going to be 1.5-ish moles. So that's B. So, but this one here, so balanced chemical equation, 2 aluminums, 3 times 2, 6 there. So it's balanced. And we have 30 grams of aluminum. We want to know the moles of iodine that are going to react with 30 grams of aluminum. So 30 grams of aluminum, moles of aluminum, and you're getting 27 from the periodic table, which will be given to you. It's right here. So 26.982, 27. Close enough. And so then 30 grams, 27 times 3/2. So I saw this as about 1 mole, and then, so 1 mole times 3/2 is about 1.5, and since it's going to be a little on the high end of the half, so let's just be. Questions with how to do this? Oh, this is the one students hate. So I'll do green. I'm wearing a green shirt today, why not? Density of ethanol is 0.789. How many milliliters of ethanol are needed to produce 15 grams of carbon dioxide by the following chemical equation? So, do dimensional analysis. So start with 15 grams carbon dioxide, and then mole CO2 to 44 grams CO2. And that's the molecular weight. So it's 12 plus 16 times 2, that's 44. And it's 44.01, but meh. So then we got to look at moles ethanol. There is a mole of ethanol, C2H5OH, over 2 moles CO2. And I'm getting that from, highlighted in purple here, 1 part C2H5OH to 2 parts CO2. And then molecular weight of ethanol, so let's see here, 12 plus 6. Oh wait, so it's 12 times 2, 24 plus 6, that's 30, plus 16 is 46, 46 grams. Actually, not gonna, yeah, that's right, 46 grams C2H5OH, all over mole. C2H5OH. And here's where the students get messed up. It's gonna, you have to divide by the density. Okay, so divide by the density, why? To have the units work out. So 15 grams CO2, mole to 44 grams, and then by the balance chemical equation, 1 mole ethanol to 2 moles carbon dioxide, as shown there. And then 46, that's just the molecular weight. 12 times 2 is 24, 6 hydrogens, 24 plus 6 is 30, plus 16 is 46. 46 grams ethanol per mole ethanol. You don't have to do it in your heads, by the way. In fact, if you have a hard time doing the math, you can just write it down. It's probably a lot better. I'm partially showing off too, in case you're wondering. Then, to get the units right, and it wants milliliters of ethanol. So notice, since grams are here, you have to divide by the density to get the milliliters. What is the answer to that? So that'll be about
You went through that one
10-ish.
really fast.
What?
You went through that one really fast.
That's about 10 milliliters. Okay. All right, we got 50. So slow it down.
Yes.
If the density of ethanol, I'm kidding.
I was afraid they're all of you.
Okay. So, question: if the density of ethanol is this, how many milliliters of ethanol are needed to produce 15 grams of carbon dioxide by this equation? So when you set this up, right, dimensional analysis, you start with what you're given, and this, well, you're given density of ethanol, 15 grams of carbon dioxide, and a balanced chemical equation. So start off with your product, 15 grams CO2, and you got to convert from mass CO2 to moles CO2 moles CO2 to moles ethanol to mass ethanol, and then using the density then to the volume of ethanol. So make the units work out. Then, so start out 15 grams CO2 and use a periodic table, 12 plus 16 times 2 or 44 grams CO2. And then from the balanced chemical equation, mole ethanol to 2 moles CO2. It's written there in purple electronic ink. And then now that we have, so right now we're at moles ethanol. We have to multiply by molecular weight, which is 46. So it's 12 times 2 plus 6 times 1 plus 16, 46. And then to get the units correct, you have to divide by the density because you have to get rid of the grams ethanol and then get the volume of ethanol. And carrying it through, that's about 10 milliliters in that range, so I think it's D. So is that slow enough, or does anyone have any specific questions? I mean, we're blowing right through this, so if you need me to slow down, I can slow down. Okay. So which of the following pairs of aqueous solutions will form a precipitate? So I'm going to use different colors, and so you have to ask yourself, so I have in yellow and violet, if you're colorblind to different shades, I guess, I don't know. But the question is NH4 going to combine with CO3 to form a precipitate, and will Li combine with NO3 to form a precipitate? For that one there, then likewise, I use different colors. Silver and nitrate, and I'll use complementary colors. Copper and acetate. So will that form a precipitate? And let's see here, we'll do, although a lot of people, silver and iodine, and then lithium and nitrate, and then what color should I do? I don't know, I'll do pink, why not? Sodium and phosphate, and then I'll do gray, lithium and chloride. Okay, so you have to look at each of these, and by using the solubility chart that's given to you here, and notice a couple things. All alkalis and ammonias are soluble, all nitrates and acetates are soluble. So ammonia, acetate, these are all soluble. Acetate and nitrate, it's all soluble. These are two alkalis, that's all soluble. So if anything, it will be part C. And lithium is an alkali, it's always soluble. And then you look to mercury, and the question is mercury iodide. So your question is it Hg2I2? So then you look to the chart, and you can see iodide tends to be soluble with the exception of mercury. So since mercury is an exception, and this is actually insoluble, this means that this forms a solid and it will go down in solution, and then the answer to that is C. And I will put a silver box around what you're looking at. So you get that, you have to look at each one, determine if it's going to be soluble, like you're going to trade partners. So the positive ion's going to get with the other negative anion, and the other positive, and And so they're going to trade partners. You have to figure out, like, okay, is that going to have a reaction? Is it going to form a new substance that's not soluble? This one, nope, because alkalis and ammonia. Part B, it's an acetate and a nitrate. Those are all soluble. Part D, alkalis, all soluble. Then you're like, okay, will lithium nitrate? That's no, all lithiums, all nitrates are soluble. What about mercury iodide? Look at the chart. Turns out that mercury iodide is an exception to the rule. Therefore, that forms a mercury iodide precipitate, and that's the one that forms precipitate. You have a question?
No, I'm good.
Okay. Any other questions? Any phantom questions? Phantom questions that you're too afraid to ask? Okay. I'll go back to blue. I like blue. How many molecules of hydrochloric acid are formed when 50 grams of water reacts according to the following balanced reaction? Assumed excess ICl3. So, and it's asking for molecules, so what you do, so start with what you know, 50 grams of water, and we're going to convert to moles. Mole H2O to 18 grams water times, and we want to, so HCl, so there are 5 moles HCl per 3 moles water, and then there are 6.02 times 10 to the 23rd molecules HCl per mole HCl. So this one here, so 50 grams of water, what's given, and this is the limiting reagent because it says excess ICl3. So convert to moles, and then we have a 3 to 5 ratio here. And at this point in time, we're at moles HCl. It's asking for molecules HCl, so you multiply by Avogadro's number. Avogadro's number tells you the number of molecules or whatever units in a mole. So let's see here. This is going to be 1.5 times 5/3, so 10/3. That's 3 1/3, so 3 times 1.8 times 10 to the 24. So D. Is that right?
Do you need to worry about the assumed excess ICl3?
That just means that water is your limiting reagent. Is it D? 14. Hey, I screwed something up. What did I do? All right, let's put in my calculator. Oh, wait. What did I do? No, wait, that's 2.5. Oh, I did 2.5. Okay, shoot.
Should be 2.78.
Yeah. Let's say, oops. I did 50 divided by 20 and put it as 2. Whoops. 2.5. That's what I did wrong. Okay. Those are all pretty close. I guess I did the calculator for that one. All right. Getting tired. Questions with this one? So again, this one, just make sure you watch your units and what they're asking for. These are all, a lot of these problems are the same. It's just kind of a different variation from it. But 50 grams of water divided by molecular weight of water times the balanced chemical equation, 3 to 5 here, and then the mole. Questions?
Seems so easy when you go through it, but then it's like you're on your own and you have no idea what to do. At least for me, that's my situation.
I just remember grams to moles to moles to grams.
Well, hopefully you'll sleep on it and it'll be so second nature. I mean, I have been doing this for quite a while.
Can we get like 2 or 1, ask the teacher, can you give us the answer?
Sure, I tell you what, after the test is over and everyone gets it back, you can ask all the questions you want.
Very partial credit.
We'll see. Okay.
For partial
I'll,
credit.
do a,
My hands
I'll,
are very
I'll play a full game of Risk with you for extra credit.
Oh jeez, I don't think either of that was enough time. Man. Yeah, we'll be done. We'll be done by February.
Quick question, when we determine the limiting reagent, are we comparing the moles or are we comparing the grams?
Either one.
Oh, really, so whichever one's less is the limiting reagent.
It's honestly, it's whatever you choose. I do the grams. The book does the moles.
So that doesn't really make a difference?
No, no.
Just one less step.
So, question. I like to set it all up and then calculate it out, and then I choose between the two. That's my own personal choice. Okay.
Around 15.
Automotive airbags inflate when sodium azide decomposes to sodium and nitrogen. By the following equation, 2 sodium azides form 2 sodium metals plus 3 nitrogen gases. How many moles of nitrogen are produced from the decomposition of 2.88 moles of sodium azide? So it is 2.88 moles Na-N3 times 3 moles N2 to 2 moles Na-N3. So 1.44 times 3, 4.34. Yeah. So E.
That's it? That's what you do?
Yep. One stepper. Yeah, some are easy, some are hard.
But they're all gonna be easy, right? Because we took the poll.
Well, I mean, everything is relative.
I'm just kidding. I'm like back and healthy, so now I'm giving you a hard time.
It's okay. As you can see, I'm deeply offended as usual.
Where'd you get the 2.8 from?
Right here.
Oh, I see it.
Yes, Michael.
Which solubility questions are going to be on the test? Like, what kinds? Because there's the one where you have to like figure out the rest of the chemical equation and then balance it, and then you have to find if it's like this was a homework. I'm just wondering if like problems like this are going to be on.
It'll be ones very similar to this test. It's either going to be a number that's soluble, or if you have there's definitely one that has the mixtures of things and determine if there's any precipitate.
I understand that one. I'm just wondering if there's like it starts off with two compounds, and then it wants you to find if it's going to form a precipitate, but first you got to like balance it out.
No.
We did that in lab today.
Yeah. No.
Okay, good.
So, I mean, it helps to have working knowledge of the charges, but the thing is, since this is multiple choice, that's kind of given to you anyways. You're talking about the precipitation lab where you have to balance the charge and all that kind of stuff?
I haven't been that yet.
That's a bitch.
You're not bad, especially like class.
So, but it'll be excellent practice for your test, but I guess you don't really have to do that though. That's also just general balancing equations and getting used to the ion names and that kind of crap. So, other questions? Been very silent on stage right here. You guys doing okay? Okay. Ooh, here's the one that you talk about, grams. Determine the limiting reagent and the mass in grams of nitrogen that can be formed when 50 grams of N2O4 and 45 grams of N2H4. Some possible molar masses are as follows. N2O4 is 92 grams per mole and N2H4 is 32 grams per mole. Okay, so if I want to use the proper names, N2O4 is dinitrogen tetroxide, and N2H4 is dinitrogen tetrahydride, also known as hydrazine. That is a common name. All right, let's pick a color. I'll do black, like my soul.
That's what we're twins. Both from Ohio, both got black souls. Well, you should really chill.
All right, so we don't know what the limiting reagent is, so we have to do this twice. So start with 50 grams, and what is it? And is my 204? My pen just stopped working. And the other one is 45 grams N2H4. Okay, so let's start with N2O4, and there is mole N2O4 for 92.02 grams. N2O4, and what are we looking for? We need the mass of nitrogen. So there are 3 moles N2, 2 for every mole N2O4, and I'm getting that from this, and then 28 grams N2 to mole N2. It's just 14 times 2. Bottom one, mole N2H4 over 32.05 grams. 32.05 grams N2H4, and there are 3 moles N2 to every 2 moles N2H4, and I'm getting that from that times 28 grams nitrogen to mole nitrogen. And yes, you can stop at moles if you want. So, but you still have to multiply by 28. This is my own personal preference. It's whatever you prefer.
Whatever
You're
you
gonna be
fancy.
looking for the grams anyway, so.
Yeah. Yep. So the first one is 50 divided by 92.02 times 3 times 28. And this is 45.6. And the bottom one, grams nitrogen, so the bottom one is 45 divided by 32.05 times 3 divided by 2 times 28, and this is 59 grams nitrogen. So then because of that, this is the limiting reagent, or I should say this is the limiting reagent. And then it's B, 45.7. I'm getting 45.6, but listen. Yes, Emma.
This might sound dumb, but how do you know which one to put on top? Like when you go through everything?
Okay, so when you're doing these, you always want to put the one on the bottom from the preceding one. So, and kind of the idea when you're given a mass of something, first thing I'm trying to get, like, oh, convert to moles. Once I get to moles, then I'm like, okay, convert to moles, and then I can look at the balanced equation and figure out, okay, what are the moles of the thing that I want has, and after I figure out the moles of that, then I can go further. If it asks for mass, I multiply by molecular weight. If it asks for molecules, multiply by Avogadro's number, that kind of thing. But when you do that, make sure that you're getting rid of the other units. So if grams are here, make sure grams are in the bottoms. If moles of this is here, make sure moles of that are on the bottom. Same thing, if grams of this, make sure the moles of this are on the bottom so they cancel. So it's just to make sure that they all line up canceling. Other questions? All right, what's the oxidation number for chromium in potassium chromate? And the answer is 6. But anyways, how you solve that? So the way you solve this one, so 0, and you'll be given the rules. So you will be given, oops, I guess I shouldn't have got out of that. You will be given this set of rules. What?
Cannot see.
Rules for
Oh, all of
symbols.
those. Oh.
Yeah. So you'll have it on a sheet of paper.
You got a lot of printing to do.
Yeah, I know.
Do we get to keep the copies after, so I have to reprint?
After everyone does it, because there's always a few people that won't make it to the test, and I give them a week, and then I will post a key and give everyone the test back. Okay, but rule number 3, 0, the charge of so for a neutral group of atoms, so a neutral formula unit, 0 is equal to 2 times potassium plus chromiums plus 4 times oxygen. And you look at the chart, potassium tends to be +1, oxygen tends to be -2. So 0 is equal to 2 plus Cr minus 8, which is Cr minus 6 equals 0, which implies Cr equals 6, which is C.
Oh, yeah. Because you went them. I was just doing that.
Does anybody have any questions on how to do this? No one, stage right, being quiet, no one has any questions?
Using back in on that real quick, I'm just gonna take a picture of something and write it down fast.
I'm gonna send this out to everybody as well.
Okay.
Did you get my bald spot?
I actually only got the top of your head. That's exactly.
Oh, nice. So I recognize that shine head.
Name this head. I'll not post it online without your permission.
I don't care. Except if I ever win the lottery, I hope I'm anonymous.
So this one is asking for molecules, so when you do it, you have to include Avogadro's number, yeah?
Yes.
Okay.
So this one's a little tricky though because you don't have to use the molar mass. It's just there to throw you off. Okay, so here, so you have how many molecules of sucrose are contained in 14.3 milliliters of a 0.14 molar solution. So we have 0.14 molar is moles per liter, and how many milliliters? 14.3 milliliters, but then there are 1,000, oh wait, I got backwards. A liter is 1,000 milliliters, and now that'll give us moles. Then we have 6.02 times 10 to the 23rd. I'm getting tired. Math is exhausting. No, seriously, if you're thinking hard is equivalent of jogging. It's 100 watts.
But it doesn't burn calories.
It does. No, it does. It's 100 watts. Well, watts is 100 joules a second. So, means if I think like this in 2 hours, I'll burn a candy bar. Okay, yeah, and that all cancels out. Right, so notice that the milliliters, the milliliters here, the liters there, and then the moles there kind of go away, and we're left with molecules.
See, that's what I mean by how do you know what goes on top and what goes on bottom? Because you just went from
You want to do it diagonally. So
Yeah.
you have like moles on the top, you need a mole on the bottom to cancel
so
out.
14.3. Should there be some like one mole on the bottom of that?
Well, I mean, with this one, it doesn't fit as well because this is a moles, but I like to start with what's given on the left.
Okay.
I mean, if you want to rearrange it, if it makes you feel better that way, you can do it this way, 0.14 moles per liter. So then you go liter to 1,000 milliliters, and then 14.3 milliliters. But then still you have this 6.02 times 10 to the 23rd. You know.
It's a ratio, so you can
Yeah.
vary it anyway. And you make it so it's one on the bottom, one on the top, so they
Yeah.
cancel.
So you're
You
trying
flip
to.
it any way you want.
So let's say you have a milliliter here, and you have a milliliter at the bottom. You have a liter here, and you have a liter at the top. And you have a mole here, so you have a mole on the bottom to get to your molecules.
You're just skipping over a couple things. Yeah. You're from like liter to milliliter to liter.
Well, okay, so let's talk about concepts. Concentration, so this molarity, so M means moles per liter. So the way you get from concentration to amount is you multiply by the volume. So if you take your concentration times your volume, you get your amount. And you're trying to go for the amount. So that's why you take your concentration times your volume, but the volume are the wrong units, so you have to convert the volume units.
Okay.
And now that you have your moles, now you can convert to molecules.
Okay.
Does that make more sense?
Mm-hmm.
Okay. I think the answer is B for this one, if I remember correctly. This doesn't really matter. Oh, I don't know. 18. What is 18? Is B? Yes. Okay. So I'll go back to blue. I like blue. What is the mass of a half a mole of dichloro-difluoromethane? Okay, so dimensional analysis 0.5 mole CCl2F2 times, that's going to be mass CCl2F2 over mole CCl2F2. So you got to figure out the molecular weight of dichloro-difluoromethane. So it's going to be 12 for carbon. 12 for carbon plus 2 times 35.45 plus 2 times 19. So what is that? That's 120.9, 120.9, that's 6.45. That's 60.45. So it's A.
Oh, okay.
Okay, so half a mole of dichloro-difluoromethane. So what's the molecular weight of CCl2F2? We'll look up the periodic table. 12 for carbon plus 35.45 for chlorine plus 19 for fluorine. So chlorine times 2 plus 12. So if we're going 2 times 19 is 38, plus 12 is 50, and then 35.45 times 2 is 70, so 50 plus 70 is 120, 120.9. And just half of that, that's 60.45, or A. Questions with this one? Okay, what is the mass of a single fluorine atom? This is from your question earlier. So there's one like this. Okay, anybody want to pick the final color?
Pink.
Pink. All right, so mass of single fluorine atom. We've already mentioned this, that it's 38 grams fluorine per mole fluorine. F2, I should say, diatomic fluorine. And then mole fluorine all over 6.02 times 10 to the 23rd F2 molecules. And if you do that, I know the answer is A, so it's going to be 6.31 times 10 to the minus 23 grams per fluorine molecule. That almost looks like iron. Let me clean that up. 2. That looks like, well, it's 2 definitely, but it looks like 2. Still looks like 2. Okay. Put this one here. Mass of a single fluorine molecule. So start off with the molar mass, grams per mole, and then you divide by Avogadro's number because the moles go away and you get grams per molecule. So grams per singular units that way. It's a really small number. So, questions with this one? Nope. Okay.
So the test is also going to be 20 questions.
More space. Just to show your own work. You get your scratch paper. You can take as long as you want. After this class, we can go into the Astro Lab. I made sure the Astro Lab is clear, so unfortunately there's a class here afterwards, so if you need more time, you can
You
pick
just
up.
use your wife's classroom whenever.
Well, I have to make sure it's open first.
And
Would
then
you
yes.
rather if I went somewhere hot?
No, that's okay.
Well, because her lab's cold,
Her lab is so cold.
so.
Your wife teaches here too? Does she do
The
astronomy?
astronomy teacher, we went over this.
So does anybody want anything explained again? Any questions? I mean, there's still 10 minutes of class.
My class.
Nope. Okay. I'll bring chocolate.
But that's the safe stuff.